Yes, so we finished our Unit 31 exercise that we haven't discussed in the lessons. Here is page 21. Yes, question 4. So, here you can see we have cyclopentanol. After some reactions, it becomes CC double bond, alkene, and finally become compound Y, which don't have any double bond or hydroxyl group. Question A is describe a test. How can you show the presence of hydroxyl group? Also state the expected observations. So the answer is easy. We just use PCl5 and the result will be, here shows, steamy film will be observed. Of course, if you are given one more marks, explain your observations, you need to write down something more, is because HCl is formed. But luckily, we don't have this in our questions. Now, question B. So, we try to do the dehydration. So, suggest a dehydrating agent will be, so you have plenty of choice, but most likely we will use corn sulfuric acid. Yes, because in these questions, we haven't mentioned the physical state of dehydrating agent. So you are feel free to use corn sulfuric acid or aluminium oxide. So both of them are okay. Part C, try to draw the structure of X. So let's see what is compound X. Well, compound X is here. So after our cyclopentanol undergo oxidation as a secondary alcohol, so after oxidation, it will become a ketone. Hope you still remember. Our answer will be, now first, we draw the pentagon. Next, we add a CO double bond, like this. Well, next one, cyclopentane, which is an alkene, we add with hydrogen to give compound Y. So this is hydrogenation. So you will ask what kind of catalyst is. Yes, we have many choices, but I prefer you to write down those common ones. For example, palladium and nickel. Now palladium I do not recommend because the sparing is not easy because we seldom use that. Well, next, cyclopentene react with bromine solution. Right, this is an addition reaction. So the observable change easy. Yes, from orange brown to colorless. So some of you may wonder, is it orange to colorless or brown to colorless? So I recommend you to write down both actually. Structure of SAT. So what is SAT? Let's see. Yes, compound SAT is the product after the addition reaction. So we just copy down. Originally is here. You can see the double bond I have removed already. Then we add 2 bromine and this is done. But finally, the question mentioned the cyclopentene undergo polymerization. So you are required to draw 2 repeating units. Remember our template in drawing the polymers. Our template is like this. Still remember? Yes. So we apply this to our questions. Yes. So you can see I have finished the left hand side with 2 monomers. So what should we do is we break the CC double bond like this. So you can see there is a new bonding formed between 2 molecules and that's it. So for question 5, so this is a question about the production of ethanol. So we have this strange device. And if you study biology, so a mixture of grape juice, water and substance X, maybe you will familiar with that already. Finally, the Y contain ethanol. So first, state one substance that can convert into ethanol. and write the chemical equation for this. Right. So I suggest is glucose C6H12O6, and after the fermentation it become first 2-alcohol or ethanol, more precise. Don't forget we have 2 CO2. So if you study biology, so you will learn this before, I think. Second is suggest X is, well, X is the substance that used to produce alcohol or ethanol. So of course X is yeast, which is a kind of bacteria. The function of the yeast is to start fermentation, or you can write more is used to break down the glucose to produce ethanol. So what is this strange device? So you are asked what is the function of Y. So you can get some insight from our chemical equations. Yes, CO2 is formed during the reaction. And of course, you may expect that bubble will be formed. Actually, during the fermentation, you will get some bubbles. Okay, if you trap them and do not allow them to leave, then your alcohol drink will be bubbled, just like beer. But in our case, if do our fermentation in a closed system, build up of pressure is a big problem because it may break our container. So the function of Y first is it allows the escape of the CO2 form to prevent the build-up of pressure. Here is the first point. The second point is because fermentation must in an area that without oxygen, so the device of Y prevent the incoming of oxygen from outside. Because if air or oxygen comes in, then we will get further oxidation to form carboxylic acid rather than forming alcohol. So the second function of device Y is prevent oxygen coming into the jar like this. So there are two functions, or you may say this is a valve if you study biology. Well, finally, so we have come across these questions in lessons. Why the concentration cannot exist above certain level? Yes, because the alcohol form will denature the bacteria or denature the yeast. Here we will use some scientific term. We do not say kill the bacteria or kill the yeast. We will use the word denature, which is more precise. So I recommend you to use the word denature rather than kill the yeast. So what should we do if we want to get the alcoholic drink with alcohol concentration higher than 80%? We just carry distillation or even fractional distillation if you want to get pure ethanol. And finally, why the glass of wine turns sour in air? So we have discussed before. Because under the action of bacteria, the alcohol will turn into ethanoic acid when we stand in air, which is an oxidation. And of course, if you are drinking ethanoic acid, it tastes sour. But here I want to emphasize one more is the oxidation will not be too fast without the action of bacteria. So that's why for those alcohol with low concentration, they will turn sour. But if the alcohol got high concentration, for example, vodka, they will not turn sour because under such high concentration of alcohol, the bacteria will gone without the catalyst or enzymes secreted from the bacteria. The oxidation will be very slow. I add an amendment here, make you understand. Well, next is page 29. We got two multiple choice we haven't finished. An alcohol and carboxylic acid heated in the presence of corn sulfuric acid. Okay, this is kind of esterification. Yes, we got the following compound here. So what will be the combination? As we mentioned before, every time we cut the molecule between two oxygen here, like this. The one with oxygen single bond belongs to alcohol, and the one with CO double bond belongs to carboxylic acid. So you can see, for the carboxylic acid, we got 3 carbons, either boy or dog. But for the alcohol part, we only have 2 carbons. The answer is boy. Again, it looks complicated, but we try to draw the compound by ourselves again, like this. So we do the same job. Cut the molecule into 2. This belongs to carboxylic acid, and this belongs to alcohol. Right. So the carboxylic acid is either C or D, because we got only 2 carbons here. Well, what about the alcohol? So let's try it. 1, 2, 3, 4. The parent chain got 4 carbons with 1 branch. So of course, this is butyl 1 with methyl group. So our answer is C. Next is page 32. So we do the examples about the hydrolysis. Every time we do the same job, I just show you the answer. The first 2 questions is shown here. So feel free to leave your question to me if you don't understand. The third questions are a bit tricky because you can see this is alkaline condition only. So no carboxylic acid is formed afterward. So we should do it carefully. Again, we break the molecule and I showed you the answer. Yes, you can see for the alcohol part, no problem. But the carboxylic acid become carboxylate, which is an anion, because this is an alkaline media. If no problem, then we move to the last 2 questions. We are trying to break the ester with ring structure. What should we do? It's same. But in case you are not familiar with the strict chain structure, I recommend you to do this way. So you can see, I try to break this bond only. Well, the next one is, I try to add a hydrogen here to illustrate the alcohol. And for this one, I got a small OH here to illustrate the carboxylic acid. Well, this is suitable for those students who are not willing to draw the strict chain. But if you want to have a challenge to yourself, then you can mark the number here. This is a pentagon. The 5th one is oxygen. After you break it like this, or you can draw the strict chain. Here is 1, 2, 3, 4. Both of them are carbon. But don't forget, the 5th one is oxygen, right? So after the hydrolysis, here first, position 1 will connect to a new OH, while the position 5 here will connect to hydrogen, like this. Both are welcome. Finally is we got 2 ester functional group here. We do 2 hydrolysis. 1 and 2. After you break it, the 2 side belongs to acid and the middle part belongs to alcohol. So we copy the alcohol part first. And what about the acid part? Yes, so you can see I try to copy the structure directly. But don't forget, we got 2 carboxylic acid here this time. Well, the later one, we do the same job. Break the molecule. Now, for the acid part, this is propanoic acid for sure. So what about the alcohol part? We need to draw the structure like this. So this is propan-2. So our answer is D. Next is page 33. It's question 2. So as usual, we are request with the molecular mass and the percentage of different elements. We need to find the empirical formula. So the calculation is very easy. First, we assume there are 100 grams of compound X. You can draw a table to make the calculation more convenient. With the mass, then of course the number of mole. So this is easy to with a calculator. Then is mole ratio. We choose the one with smallest number. After round off, we got 3 to 6 to 2. So the empirical formula is C3H6O2. But the story hasn't ended because we need to find molecular structure with molar mass. So let X be C3H6O2 bracket N. So we need to find the value of N. With the molar mass, we got the N equals to 1. So we got the formula, molecular formula of compound X. So what about the IUPAC name of compound X and compound Y? So let's see. Compound X, hydrolysis of compound X become ethanoic acid and compound Y. What should we do? If compound X is formed by ethanoic acid, then its structure should be the acid part according to the molecular formula. The alcohol part should be like this, highlighted in red. The compound Y, it should be methanol. So let's write down the answer. The Y is methanol. X will be labeled the alcohol part first, followed by the acid part, methyl ethanoate, like this. The catalyst used to speed up the breaking down or hydrolysis of compound Y. What should we use? Because during the hydrolysis, eventually we got a carboxylic acid. That means it should be in acidic condition. I recommend you suggest a suitable catalyst. I recommend to use sulfuric acid and with heat or reflux. What about if you use alkaline condition? Then you need to add strong acid at the end to make the carboxylic acid come again. That's why I do not recommend you to do so, because it's quite complicated. Well, next one is suggest a chemical test to show the presence of carboxylic acid. This is the test of carboxylic acid. So I recommend to use sodium hydrogen carbonate solution. Now you should remember to label solution, because without the solution it cannot show the acidic properties. So this is critical. And what about the result? Yes, if there is carboxylic acid, will give you a colorless bubble. Finally, what is the structure of compound Z? And don't forget the name. So let's see. Compound Z is the ethanoic acid after the action of ammonia and heat. So we can expect you form an amide, even amide, with this structure. Right, this is 33, page 34. So you are given an ester, given the reactant. So what is the catalyst used? Okay, easy. This is corn sulfuric acid. Next one is, so what about the diagram of reflux? So let me show you the diagram first. Now, here is the diagram we needed. So let's see which components are necessary. First, of course, the water in, water out, and the labels. And don't forget the heating, right? The next one is here. You should show that the flask, the round bottom flask or pear-shaped flask, and the condenser belongs to two different pieces of glassware. You should not join in a single way. That's it. Well, next is, so what should be the safety hazard warning label? Well, easy. Ester are highly flammable. Still remember, ester is actually the major component of thinner. Suggest another ester with the same molecular formula. Okay, good. Actually, you are trying to find the structural isomer of this ester. So we have 3 different choices, and here shows all of them contain 4 carbons in total. So here I showed you their names. Here shows methyl propanoate, propyl methanoate, and finally is isopropyl methanoate. This one is actually comes from a secondary alcohol. Again, I do not recommend you to draw or write anything that you are not familiar. So the first 2 I think is far enough. Question 4 in page 35. This is a past paper questions in CEH. First, Z present smell. So very good. This is an ester. And with this molecular formula, so the only hint is it comes from methanol with 4 carbons. One of them come from methanol. Then of course the carboxylic acid part contains 3 carbons for sure. Here we go, like this, right? Next one, what homologous series X belongs to? Of course is carboxylic acid. So what about the systematic name of X and Y? Well, Y is easy because Y is propanoic acid, right? But what about X? The carboxylic acid is come from X after oxidation. So X can be 2 possible choice. Now, this is a good question. X can be most strictly is propanol, very good. But if you think twice, you can find that X is actually possible for propanol. Don't forget, an aldehyde can be oxidized to form a carboxylic acid. So don't limit your imagination. Finally, what will be observed if X is mixed up with dichromate solution in acidified? It will turn from orange to green. In page 37, so here we got another hydrolysis problem. Again, I give you the answer first. Please feel free to ask if you don't understand. Again, the first 2 are quite trivial, right? But I want to emphasize is when you try to do the hydrolysis questions, try to write down with H2O. It shows a better idea of doing hydrolysis. For the final questions, yes, I show the answer here. For the final questions, again, I try to use the same method again, right? First, give them their numbers, and next, I draw the distance between 1 and 7 a bit further to allow me to add the OH and hydrogen here to finish my job. Now, yes, this is enough already. I have break the bond of amide already. So of course, if you want to build a strict chain, here shows. Don't forget, number 7 is nitrogen. We add the OH in number 1, another H in 7, and that's it. Well, next, so what is the function of sodium hydroxide when we try to hydrolyze the amide? Yes, it is a certain type of reactant because after we break the amide, we neutralize the carboxylic acid, so it will consume. So of course, it is a kind of reactant for our sodium hydroxide solution. And next is, so what will be the product? You need to ask yourself, what is the structure of propanamide? Is here. So after we break it, there are 2 components, right? The first one is carboxylate. The other one is ammonia. But it doesn't mention here. So D will be the answer because it is the only one with cation and anion shown. Next is page 38. So you try to draw the structure of ABC. We need to trace back the questions actually. Let's start from compound C. After dehydrating, it forms a CC double bond. Well, that means our compound C should be the one with hydroxyl group, right? Like this. Start from this. Cross out the double bond, add a hydroxyl group and hydrogen. Yes, compound C is ethanol. Next, let's focus on compound B. Compound B, finally, after reduction, it becomes an alcohol. That means there are 2 possible choices. Either B is carboxylic acid or aldehyde. But since compound B comes from hydrolysis, so it seems to not likely to be an aldehyde. And next, the compound contains 3 carbons. So compound B also contains 3 carbons with carboxylic acid. We got the idea. 3 carbons with carboxylic acid. And here we got compound A is an ester. What is reagent X and what conditions? Well, reagent X allow the alcohol into chloro compound. So you got plenty of choice. Either PCl3, SOCl2, Cl, all of them you need heat or reflux. But if you choose PCl5, so please in room temperature. This is reagent X. And so name of reaction in C1, C2, and C3. Let's find it. C1, we change the carboxylic acid into alcohol, so of course this is reduction. C2 is substitution because we change OH into Cl. What about C3? Yes, you get the answer. C3 is dehydration, and here we finish the job. So thank you for listening. See you next time.